Good morning, students. Okay, so far we have learned about what have we learned about? We have learned about vectors. Now today I'm beginning with a new topic, which is understanding the dependence of distance traveled with time in a uniform motion. This is what we are going to learn. It seems to be a very big topic, but anyway, there are several things which we need to learn here. A bit unconventional from the topics that you have learned in your previous classes, that is in your usual classrooms. Anyway, I thought, because if you want to do an experiment, this should be a catchy topic. Okay, it's not so easy. Just say understanding distance displacement will not be so useful. I thought, okay, this would be fine. Now, before we start with, let us begin with what is distance? What is distance? Distance, as you know, is nothing but total path length. For example, I start from point A, I go until point B. So this is the length of the path wherein I can measure it using a meter scale. Now, once again, I continue with my point B, I go to point C and take a turn like this to point D, then return back to point E. And again, if you ask me what is distance, let us say this is around 5 centimeter, this is around 3 centimeter, this is around 2 centimeter, this is once again around 6 centimeter. Then I can only say that the total distance traveled here is 5 plus 3 plus 2 plus 6, right? Don't get confused with the displacement. So now this should be 15, 5, 5, 3, 5 plus 3, 8 plus 2, 10 plus 6, 16. 16 centimeter. This is the total distance traveled. Now let us look at displacement. Displacement. Many students get confused with this distance and displacement. Displacement is nothing but the shortest distance between any 2 points. Now here, what is the shortest distance? So towards this, what we do is, we consider the point A, consider the point E. The final point minus initial point, it will be your displacement. So join this by a line like this. And now what you do is, you need to find out this value. And what could this value be? Can this value be something like around 2 centimeters, 3 centimeters? No guesses. Do not guess anything. So towards it, look at the diagram. If this is 2 centimeter, this should definitely be 2 centimeter. Am I right? And then if this is 5 plus 3, 8 centimeter, and you have come back 6 centimeter, that means this should also be 2 centimeter. Correct? I have labeled this as A, B, C, D, E. Let me label this as some F. Okay, some F4. So we have got this. Now see, this AF is equal to 2 centimeter, FE is equal to 2 centimeter. I want to find this AE. Now what should I do for finding AE? Look at this. This is a right angle triangle. So I can apply my Pythagoras theorem here. And then I say 2 square plus 2 square is equal to AE square. Okay. So 2 square is 4. 2 square is once again is 4. This should be equal to AE square. And 4 plus 4 is 8 is equal to AE. Or your AE should be equal to root 8, which should be 2 root 2 centimeter. Right? So we have got the value of AE. That's it. Okay. So therefore, displacement, we have calculated it. This distance here in this example is seen to be how much? 16 centimeter, while displacement is equal to 2 root 2 centimeter. Now, can we also say that displacement here is less than distance? Of course, definitely it is less than distance. But what do we infer from here? Let us say I give you something like a person starts walking from point A to point E. I have not given you any of these details, but I say the distance of the path traveled by him is seen to be 16 centimeter, while the displacement is seen to be 2 root 2 centimeter. Now, what do you understand from that? You can say the person has not gone only in the straight line, but also has taken deviations, and therefore, okay, he is not always moving away from me. Sometimes he is moving away from me, sometimes he is moving towards me. Can we say that? Of course. Okay, so whenever displacement is equal to distance, less than distance, sorry, then we can say the path is not a straight line. Is not a straight line always. This is what you can mention. Okay, now we have concluded something here, right? So just understanding distance and displacement is not sufficient. These are not just numbers, but they reveal you something else over here. What does it reveal? It tells you whether the particle or the person has traveled in the same distance, who is going away from me, or he has also taken a deviation and then returned back to me. That's what you can say. Now, once again, can distance be greater than displacement? Can distance be greater than displacement? Go back to this. Is it possible to have distance greater, distance, I made a mistake, displacement greater than distance? It will never happen. Okay, at any point of time when you do some calculations and you find that displacement is greater than distance, that means you are committing a mistake. This is impossible to have. Then we have seen the second thing also. Then next one is, can displacement equal to distance? Definitely it is possible. For example, if you consider the path between A to B, you see A to B here, total distance is 5 centimeter. What is the total displacement? 5 centimeter once again. A to C, total distance is 5 plus 3, 8 centimeter. Total displacement is 5 plus 3, 8 centimeter. So displacement equal to distance. So what do you mean by that? The particle or the person has not taken deviations. Or we can say the particle is not moving in a curved path. Is not in a curved path. And here we can say that it is in a curved path. It's in a curved path. And here, impossible. See how nicely using the calculations or the values of displacement and distance, you are able to infer whether the particle is moving in a straight line or not moving in a straight line. Has it got deviated or is it going straightly, right? Good. Okay, so we have understood what do you mean by distance and displacement. Now let us move on to the next one. So let me just summarize. We can say that if distance is less than, distance is greater than displacement, that means the particle is moving, is or has moved in a straight line. If distance is equal to displacement, then particle is moving. Distance, oh my God, I made a mistake here, is moving in a curved path. It's moving in a curved path. If distance is equal to displacement, particle is moving in a straight line. If distance is less than displacement, then this is impossible. You cannot have this situation at all. Then if distance is equal to 0, what do you mean by that? Distance equal to 0, which means particle has not moved. It hasn't started. For example, if you ask me, what is the distance traveled by me when I started teaching you? I'm just sitting before you, right? I have not moved. Distance equal to 0. If displacement is equal to 0, then what do you infer? You will say particle has returned back to the original point. See, I start from point A, go to point B, and take a U-turn, come back to the same point here. Then shortest distances, it is at the same point. So therefore, particles return back to the original point, or particle has not started the motion. Both inferences are true. Okay, which means some information is lost, right? When you learn, when the value of the displacement is given, that means you get some information, you lose some information also. Okay, then can the displacement be negative? Can the displacement be negative, less than 0? If it is less than 0, what does it mean? Which means it started from point A, point B. And maybe if you consider this as your positive x-axis, and the particle went back and it's at point C here. And if I ask you where is the particle, you will say, hey, it is behind me, right? So therefore, it is behind me, 2 centimeters behind me. So therefore, displacement is less than 0 means it is moving along the negative x-axis. Sorry, it is not moving. It is positioned. It's positioned along the negative x-axis. Can distance be negative? Can distance be negative? Once again, this is impossible. This is impossible. Okay. So we have learned much about distance and displacement. Right. Now when does distance increase? Or when does displacement increase or decrease? Whatever it is. It all depends upon the time. Right? Time is a very crucial factor. Okay, time is a crucial factor. And that's what it tells you whether the distance or displacement are decrease or increase. With the time, what is the position of the particle? If you ask this question, you say the particle is 2 centimeters away from you, 5 centimeters away, 7 centimeters away, and so on, right? So that is what it tells you about the distance or displacement. Then the ratio of distance divided by time is called as speed. It's called as speed, while displacement divided by time is called as velocity. Now, in the earlier classes, I have taught you about vectors. An example of this vector is nothing but displacement. And since you have displacement by time, you also have velocity as a vector. Okay, this velocity is also a vector. Thus, we have velocity is a vector because it has a direction. Why it has a direction? Because you see displacement has a direction. Because you see a particle starts from point A, I'm indicating a vector over here, okay, goes to point P A, let us say this is 3 centimeters, and again it goes to this direction, 4 centimeters, and comes to this direction, 5 centimeters, and again comes back to this, let us say 4 centimeters. And you ask me what is the displacement, I will calculate only using this value, right? I'll calculate it only using this value. Okay. Now, what is this actually? Now, let me write down something here. Very interesting to note. O, A, B, C, D. What made me to write something like this and indicate an arrow? If you remember, we have done something like addition of vectors. You see, this is one vector, this is other vector, third vector, fourth vector, and last vector is shown over here. If you want to add only these 2 vectors, I am going to just illustrate a line here like this. If you want to add 1, 2, and third vector, then I'm going to write a line like this over here. This will be your resultant vector. But if I want to add 1, 2, 3, and 4 vectors, then this will be my resultant line. Thus, we have got the resultant over here, right? Okay. So in this case, this is seen to be negative for the resultant of the vectors. So thus we get the displacement divided by time, and this gives you the velocity. Okay. Now we have learned about velocity, we have learned about time. So in your vehicles, in your automobiles, in your scooters, what meter do you have? You call this as a speedometer. Does it measure the speed or does it measure the velocity? What does it measure? Usually we have been using this term velocity wherever we go, right? We say that the velocity of the bus is 60 km/h. Okay, it is speeding like anything. Now, what do we use there? Is it speed? Do we measure speed or do we measure velocity? We measure speed over here and not velocity, because the speedometer only indicates what is the speed of the vehicle, okay, and not the velocity of the vehicle. Okay. Now let us start with the next one. Let me share my screen. Right. You observe that there is a person standing here, and there's a tree and there is a house here, and he wishes to go in this direction. What I do is, there's one more parameter, acceleration, which I have not taught you so far. I'll do it later. But currently, let us use only position and velocity. He is at the 0 position and the velocity is over here. Now, what I want to relate is, I wish to relate the distance taken by the person with respect to time. Okay, and then I'm going to keep this at something like 0.5 meter per second. Now he is going to move in the forward direction. I have a distance. Okay, nothing else I'm going to do. Now, what is my interest? Now, my interest is to find out how much distance the person covers in what amount of time. Okay, let me go back to my screen and let me write down, because we are doing an experiment now. And while we do an experiment, two things become very important. We need to write what is our independent variable, dependent variable, and control variable. Now, what is the aim of the experiment? The aim of the experiment is to relate the distance traveled by a person with the time taken by him. Now, what is your hypothesis? Your hypothesis should be, now what is it we have seen the experiment? We have seen that there is a velocity. What did we do? You put the position at 0 and you have made velocity to be equal to 0.5 meter per second. What does it tell you? That he is going to move with a velocity. Now, that's what we have seen. We are not going to stop him at any point. So he is going to move. Now, what do you expect? Now, what did we say in the previous data? I said that velocity is equal to displacement by time. Velocity is equal to displacement by time. Which means when he starts from here, he starts moving like this. The position is going to keep on changing like this, right? As he moves away from this point O, the time is also going to increase, right? As you increase the time, the person is not going to stand, it's kept on walking like this. Okay, this is what is velocity. So you are going to find out what is the distance traveled by him and what is the time taken by him to move like this. You are going to divide one with the other, and then you are going to find out what is the velocity. This is just very simple experiment. Now, what is my independent variable? Which one do you think would be better for me to take it as an independent variable? I would always prefer distance traveled by the person to be an independent variable. And I will calculate what is the time taken by him, okay, to travel a given distance, which would be my dependent variable. Okay, for some reason. Okay, the reason I'll put it across at the end. So until that, let us assume that this is what I'm going to consider. Okay, and now what is my control variable? What's my control variable? Control variable is that, see, the displacement of the particle can increase if the velocity was increased, but I'm not going to change this. So my velocity would be my control variable. The speed of the person is that control variable, right? Now let us draw a tabular column. Now, what should the tabular column contain? First is SL number. Every experiment will begin with an SL number. Then what do you have? Independent variable. What is your independent variable? Displacement. Displacement. Unit, it should be in centimeter, right? See, the moment you write the variable, you have to write the unit immediately. Then what's the next thing? Time taken. Time taken. I am definitely going to put 3 trials here. In the previous experiments, I didn't do that. But here, I am definitely going to put it for 3 trials. You have to let me know why. T1, T2, T3. That's it. Before we start an experiment, this is the first thing that we need to do. And what is the unit? Seconds. Okay. Now, we'll start with the experiment. Let me share my screen once again. Let me go to the lab page. Right. Now you see, this is 0.5 meter per second. Acceleration is 0. And then this is 0 here. What am I going to do? As the person starts walking, when he reaches, oh, this is in meters. Okay, I need to change back there. As he reaches, you have, see, it starts from 2, 4, 6, 8, 10. I think 5 trials will be sufficient, right? 5 trials. Now, let me go back to my slide and change the parameters once again. This is not in centimeters. This is in meters. And initially, this would be 2 meters, 4 meters, 6 meters, 8 meters, 10 meters. Right? Okay. Okay. So now this is what we have. Now towards it, let us begin with the experiment. Anything else I have missed? Nothing. I have missed something here. I told you about independent variable. But whenever we write an independent variable, what are all required? Independent variable. What am I going to vary? Displacement. I have written it already. What is the range of this variation? It starts from 2, ends at 10. I should write 2 meters to 10 meters. And how am I going to vary? So this is the first part, the second part, third part. How am I going to vary? In steps of 2 meters, right? So this is my complete information about the independent variable. Then dependent variable. Dependent variable. What is my dependent variable? Time taken. Time taken. How are you measuring this? In second. Here I missed it. Displacement in meters. Okay. And should I write anything here? No, you're not going to write anything because we do not know anything because this is dependent on this variable. Control variable. What is my control variable? Control variable is velocity. How are you going to measure it? Meter per second. What is the constant? What is the value of this 0.5 meter per second? Okay, so we have mentioned what is the control variable, what is the value of this. If this is not kept constant, see, very important here. The third step is if this is not kept constant, what will happen? Distance versus time will not be a constant. Relationship. We have described everything about the experiment. Now, the only thing that is remaining is we need to start with the experiment. Okay. And once we finish it, then we need to annotate this table. Okay. We have not done that. Now, let us start with the experiment. So displacement, now we are going to change it. Where is my sharing screen? Let me go back to my lab page. Right. So I started with 0. When I click on this play button, then immediately the person starts moving. When he reaches this point 2, I'm going to stop it and record what is the time taken. Okay. And here it says this 0.0 second. It means that I'm going to calculate the time for 1 decimal point. Now let us start. 1, 2, 3, start. The moment it reaches 2, I'm going to stop. What is the answer I get? 3.9 seconds. Now what I will do is, I will go to my table once again. For 2 meters, the first trial I got is 3.9 seconds. Now what I will do, once again, I'll go back to my experiment. Then I will reset all. And once again, set this value to 0.5 once again. And then let me start with the experiment, right? So this person is facing that side. Hello, please face this side. We are going to start with once again. Start 1, 2, 3, going on. Right, now it is 4 seconds. See, I'm getting a different answer every time. 4 seconds. Let it be. Let us see that. So I'm getting this answer as 4 seconds. And then once again, let us do. I will reset it once again. Say yes to it. I will make this to be 0.5. And then let us start once again. 3.7 seconds. 3.7 seconds. 3.7 seconds. Okay. For 2 meters, I have taken 3 trials. Now what I will do is, let me go to the experiment once again. Now let me do it for 4 seconds. Let me reset once again everything and make this once again 0.5. Let me start from here. Now what am I doing? I am going to count the time, the total time taken by the person to start from here and to reach until the 4 meters. Let me relax. Is nearing. 7.9 seconds. Four meters, 7.9. Once again, reset all. Change this value to 0.5. Eight seconds. And maybe what I will do is, I will consider the next trial also here. I'll remind this. Again, forth and back and forth, switching it will take some time. 0.5. Remember this, we have done it for 8. The next one. Is 7.9. This is 8, this is 7.9. Now let us begin once again. Now 3 trials we have to do for 6 meters. $11.8 first trial. $11.8. Let us remember that. What happened? Sorry, it's not moving. I reset everything. He's so tired here. It's not moving. Huh? And this guy become tired. Let us see. I think so. He's tired. There's something wrong with the program. इसको एक झटका लेना पड़ेगा. There's something wrong with the software. Just crashed ultimately. Wait, let me restart it once again. Then I probably think it might work. Okay. I restarted him. He was a bit tired. Gave him a Coca-Cola. He started with it. 6 meters. Yes. 11.9. Okay. So first time we got 11.8. Second time 11.9 now. Third time, let us do with this. Reset once again everything. 0.5 once again. It was in the same problem. Yeah. We made a mistake here. You recognize? See, this time, I think I clicked it twice. Okay, let me redo it once again. The counter was running. I didn't notice it. 0.5. I'll click it outside. Yes. Oh, I think my mouse was not working. Eleven 11.9, 11.9. Okay. So let me write down those values in the table. 11.8, 11.9, 11.9. Okay. Let us do the next one. Reset all. 0.5. Now what are we doing for? We are doing it for 8 seconds. 6 is already done. 8 meters, sorry, 8 meters. $15.9. Okay. Let us do it once again. $15.9. Remember this. $15.8. $15.9, $15.8. $15.9, $15.8. $16. Let us go back once again. 15.9, 15.8, 16. 15.9, 15.8, 16. Now let us do the next last try. $0.5. Is moving very, very, very slowly. Huh? Is it moving very slowly? No. It's because we have been looking at him for a long time. We feel that he is moving very slowly. Acha, aja beta. 10. Yes. How much is it? 19.9. Okay. Reset all. 0.5 once again. Remember this 19.9 seconds. $19.8 seconds. 19.9, 19.8. One thing that you need to know is, look at this value. I had been figuring it over here. Look at this, 9.979. It has not reached exactly 10 meters. Okay. But I have made a mistake in doing this. Okay. That is what I want you to realize it. So let me go back to this once again. So let us write down this value, 19.9, 19.8, and 20. Now you see all the values are different. I'm not getting the same kind of values. Is this acceptable? Some students, what they do is, while they do the experiment, if you get differences over here, they will write the same thing. Okay, thinking that yes, we are getting it correctly. But there's very rare chance that you will get all the three values correctly. Now, why do we get this kind of differences? The reason is because when I watched there and when I clicked on my mouse button, there is a small reaction time. That's what I want you people to focus. A small reaction time. Usually the reaction time is around 0.1 second. Okay, so that's what we have got here also. Sometimes for lazy people like me, it could be 0.3 seconds also, right? So see, I got 0.3. Maybe I would have not noted it correctly. So maybe as it is moving here and there, right, I would have not seen, okay, and I would have clicked it before itself, thinking that, oh, maybe I have done a mistake in the previous one. I should do it correctly this time. Okay, that nervousness will be there, right? So all this, because of these reasons, you see, we commit a mistake over here. The first thing that you need to know is while you do an experiment, there is always a probability, there is always a chance that you will commit a mistake. Okay, mistakes are welcome in an experiment, right? Very, very important. So don't assume that every experiment would be ideal. There are experiments in history where you never got a result at all. Okay, you only get incorrect results. You try to do it like this, but you got rather a negative result. That's always welcome. Okay, so that's the reason why we do not stop our trials only for one trial for a given observation, but instead we do it for 3 trials. Because the random errors that you get over here, you cannot minimize it like that. So therefore, you need to do more number of trials to get an appropriate value. Now, to calculate the velocity, what was our interest here? Now, first is to relate the distance between taken by a person with the time taken by him. Okay, we have done this experiment. Now, let us understand. Now, this is an infographic. In an infographic, what is that we need? We need to write here, in order to relate distance traveled by a person with respect to time, the procedure followed is already described in the previous section. And the experiment was conducted according to the procedure and the readings were tabulated. Okay, you should mention why this table was arrived at. That's the first thing. First part is done. Second part, the table itself, you are mentioning the units appropriately. Then you are writing the legend here. Legend here. What is a legend? Table 1, table 2. What is it? That is a legend. Then lastly, what do you infer? What do you infer from here? As the distance taken by the person increases, the time taken by him also increases, right? I inferred something. Okay. So thus we have conducted an experiment. But in addition to all this, you also get a bonus. What is the bonus here? The bonus is, now this is your raw data. Raw data. Next, you are going to process this data. What is processing of data? So you are going to write processed data. What are you going to do for a processed data? You are going to write one more table. Write SL number, distance or displacement, whatever it is you have written earlier, in meters, and then average time. And then after that, velocity in meter per second. Now what do we need to do? First trial, 2 meters. What was the average time? 3.94, 3.7. Okay, so you have to show at least one calculation. Plus 4 plus 3.7 divided by 3 was your average time. So if you find out this, what is the value you get? Let me use my calculator. Maybe I can directly use here. 7 plus 9 is 16. 1, 4 plus 4 is 8. 8 plus 3 is 11. 11.6 divided by 3. So 3 3s are 9. Then you have 26. 3 9s are 27. Maybe around 3.8. 3 8s are 24. 20. Then I can just keep this as 3.87. But since everything is nearly of the order of 2 decimal, only 1 decimal place, this should be shortened to 3.9 seconds. So this is your 3.9 here. And your velocity, how do you calculate velocity? Velocity is equal to 2 meters divided by 3.9 seconds, which should be, what is 2 meters by 3.9 seconds? You can calculate it using your calculator. So I have my mobile with me. I'm going to do this. So this would be 2 divided by 3.9 would be 0.512. 0.512. So let me write it down. 0.512. A. See, this is only 1 decimal place I have kept over here. Here I should not keep it as 2 decimal places. 3 decimal places should not be there. Okay. So what I will do is first let me write it down. Okay, and then I will minimize it. Then the next one is 4 meters, 6 meters, 8 meters, 10 meters. I'm sorry, this meter should not arise here because I have already written here, so I should not write it, right? So there is a way to write the table. Okay, anything is not permitted in an experiment while you record it, right? Now what we will do is, let us calculate the average for everything. But for each and every value, you need not show it. Now, what are the values you get? 7.9, 8, and 7.9. 7.9. I'm using my calculator. 7.9 plus 8 plus 7.9 is equal to 23.8 divided by 3 would be 7.93. This should be 7.9. Once again. And then for 6 meters, let us do this one. This is 11.8, 11.9, 11.9. This is 11.9 once again. And this is next one is 15.8, 15.8, 15.8, 15.9, 60. Definitely it is 15.9. 15.9. Then 19.9, 19.8, and 20. This should be 19.9. 19.9. Now let us calculate one by one all these values over here. This is 4 by 7.9. 4 divided by 7.9 would be 0.506. 0.506. Then you have 11.9 by 11.9 divided by, sorry, 6 meters by 6 divided by 11.9. 0.504. And then 8 divided by 15.9 is 0.503. 503. And then you have 10 divided by 19.9. It seems to be 0.502. Wow, wonderful, right? See, almost for the first decimal point, you see this average velocity is nearly equal to 0.5 meter per second, right? So thus, what is your conclusion from here? You say that the distance versus time, when you found out, okay, and you found out the ratio of this, you found out the velocity was constant. That means the particle is moving with a constant velocity, right? Now, thus, your hypothesis, what was your hypothesis? Whenever a particle moves with a constant velocity, the distance would increase with time, okay? Distance would increase with time, see? Distance was 2 meters, 3.9 meters. 4 meters, 7.9 seconds. So as you see, when distance is increasing, time is also increasing, provided the velocity is constant, right? We have verified our hypothesis, we have verified our data, everything is in support of it. We have successfully conducted an experiment. Got it? I hope you would have enjoyed this trial. So the next class we will see much more. What is that we have learned so far? We have learned how to conduct an experiment with a simulation engine. And there are places wherein you need to conduct more number of trials. And lastly, you have also understood that there is a reaction time whenever, okay, measuring things using a subjective phenomena. Subjective in the sense, it depends on me. Okay. So if I put my grandfather here and ask him to do it, okay, the moment he tries to click it, it would have taken, okay, something like not 3.9, it would have been 4.3 seconds also, right? So therefore, there are some people who will take a long time. There are some people whose memory is very sharp. They are able to do it, respond immediately. So therefore, it all depends on the reaction time. So how important is this experiment? The experiment was very important because we were able to realize what was my reaction time, right? My reaction time was seen to be 0.1 second nearly, except for the first one. Okay, most of the time it was seen to be around 0.1 second. Okay, I was not able to successfully get the value, okay, for 0 seconds, but definitely every person in this world will have some amount of reaction time, and that is what I got. Okay, so with this, we will stop here, and in the next class, we'll continue with the further ones, wherein we will learn what happens to the distance versus time if the velocity is also changing, right? Here we have kept the velocity to be a constant. In the next class, we will look at what happens if the velocity is also changing. Thank you, friends, for watching. Like, share, and comment and subscribe to my channel for further updates. Thank you.